This is Chapter 14 Notes, and we're moving on to ionization energy. Ionization energy is the energy required to remove an electron. So energy to remove an electron, and I'm going to abbreviate that E minus. So energy to remove an electron from a gaseous atom, meaning it's in the gas phase. And in particular, we're going to be interested in the first ionization energy. So first ionization energy, and I'm going to abbreviate that IE, is the amount needed, amount of energy to remove the first valence electron. That's the one that's going to be the easiest to remove. It is farthest from the nucleus. So, for example, let's populate lithium's principal energy levels and sodium's with electrons. We're going to look at the group trend. So we're going to go from lithium to sodium. So we have 2 electrons and 1 electron. We've got, let's see if I can draw that in there. We have 3 protons in our nucleus. When we go to sodium, we've got 11 protons. And then we have, again, 2 electrons in the first principal energy level, 8 in the second principal energy level, and the valence electron in the third principal energy level. So in terms of the energy required to remove an electron, the farther it is from the nucleus, the easier it is to remove. So if the valence or electrons are in a higher principal energy level, they are going to be farther from the nucleus. It is much easier to remove them. So this electron is easier to remove, whereas this one is going to be harder to remove. I'll use the analogy of a woman holding a purse. If a woman holds a purse close to her body, it is difficult for a purse snatcher to get the purse. If a woman holds a purse farther from her body, it is easier for a purse snatcher to steal the purse. So the farther the electrons are from the nucleus, the easier it is to remove. So group trend, as we go down a group, the ionization energy decreases because it takes less energy to remove the electron. Now let's take a look at ionization energy as we move across a period. And we're going to compare lithium to neon this time. And we have 3 protons in the nucleus. We have the 2 electrons in the principal energy level, and then the 1 valence electron. Here we have 10 protons. We have 2 electrons. That's hard to see there. And then we've got a 3rd electron in the valence shell. Notice that this electron is much closer to the nucleus than it is for lithium's. So this one is going to be harder to remove. Whereas this one here is going to be easier to remove. So as you move towards the noble gases, group 18, or 8A if you're doing the old-fashioned way of labeling the groups, you're going to feel an increase, or the electron will require an increased amount of energy in order to be removed. So the reason is the valence electrons feel a greater effective nuclear charge, So it takes more energy to remove them.